Okay, we're gonna get started. I promise you that you'll see more of Brandy after this, I think. Seeing too much of me. So just before we start this session, I just want to take a moment to just remind us all that today is Veterans Day. And it's particularly appropriate here because one of our panelists is a veteran. Raise your hand, Tim. All right. So if we could just give him a round of applause. Anybody else that's a veteran? Myself? I have two sisters and a brother that are all veterans, and I was in the Marine Corps Reserves for a few years. So really great. Thank you for your service. All right, so we've got a great set of speakers here. This session's gonna be a little different. We're gonna have, it's our plenary session. We'll have 4 speakers in rapid fire in a row. Hopefully we'll have time for questions in each. So we're gonna start with Lana, and if she'll make her way up here. Yeah, here's the click. And so Lana is our representative from Amazon Web Services. So we do, we have a growing relationship with Amazon these days. If you haven't been paying attention, is it Kalashnik? Did I get it right? Kalashnik. All right, not too bad. I love this about her. So again, I like to get something interesting here. Of course, she's a terrific lead architect at AWS, but she was born in the Ukraine. She's a Texan, so a Ukrainian Texan to start us off. Go ahead, Lana. Thanks.
I also live in Brooklyn now, so adding that to the mix. Alrighty, so today I wanted to talk a little bit more about what we're seeing in the industry and how we're approaching the topic of blockchain. I think there's been a lot of hype in the industry, a lot of POC fatigue, and I want to just give you a little bit of a perspective on how we're looking at this technology and how our customers are using blockchain and even at large cryptographic verification. So how do we think about blockchain? For the longest time, we were a little bit skeptical on the impact that it could have on some of the more traditional use cases that are much easier solved with centralized databases. So we've done a lot of due diligence on understanding how are customers actually using blockchain. For example, in healthcare and life sciences. Is this the new killer app, or it's just a buzz that's here today and gone tomorrow? The same thing for blockchain in logistics. What does that actually mean for our customers? And what we found is that there are 2 distinct categories of use cases and where blockchain was being applied. The first one that I wanted to talk about is systems that actually need a centralized ledger. So we were seeing that customers do need to verify and track, let's say, hospital equipment, track vehicle history or of ownership or title transfers. And in this use case, we worked with DMV. That's an actual production use case now, and HR and payroll. But in this use case, we found that there was no need for decentralized management of this ledger. Some of the challenges that our customers were facing is that they were starting to build homegrown solutions. So as you can see, in most databases, when you're building them out, usually audit logs is an add-on, and it's very difficult to verify if it's accurate or not. So we're trying to make sure that we are preserving these changes to assets or the provenance or history of ownership, but at the end of the day, you can't verify this log. Also, you're adding additional processes. So when you think about the way that customers were using these technologies, they're actually creating a lot of overhead from the compute perspective, and at the end of the day, you couldn't specify who's watching the watchers. So it was failing due to lack of cryptographic verification. A lot of our customers are looking to solve these solutions with blockchain. So, and a lot of them very quickly realized that blockchain was designed with a different purpose in mind. It was designed with the need for decentralization, and it added unnecessary complexity. So, and I think a lot of the POCs that we've seen that didn't go well were because of these reasons, a poor fit. And then we discovered that there is a different set of customers that actually did need transactions with decentralized trust. So these users actually wanted to build networks or consortiums that could trade or perform business transactions across countries' borders. So this is your complex supply chains, let's say was aspects like trade finance, where you need to make sure that the custodianship and the right permits are are issued to each party within the process. Mortgage lending, so this is syndicated loans. We're also seeing a lot of use cases right now popping up around insurance and reinsurance business, where you do have multiple parties that could be exchanging this information that are mutually distrusting. And retail. So this is streamlining customer experience. I'm actually preparing a talk on this topic for reInvent, which is our biggest conference, in understanding the differences between rewards and loyalties. Rewards are essentially locked within one organization. So if you buy 10 cups of coffee, you get one free. Loyalties transcend outside of the bounds of one organization. So as you're launching a product, let's say, how does it influence this system at large, or the trade network at large, and how can you quantify user experience? So in some of the complexities that we're seeing in multi-party processes is that the customers wanted to have a way to independently verify transactions and have a single current view of the trade network. And to this end, the way they usually solve this is by specifying a central authority that would be running the consortium, let's say, or employing costly escrow processes. So as you can tell, just adding another entity to just manage the network is a huge overhead, and also escrow processes were not very efficient. So because of this, our customers starting to use blockchain. I'm not going to go into blockchain. I think of what it is. I think we have a pretty solid understanding of the basis of technology. But what I do want to point out is that when we're looking at building out blockchain prototypes, we really do need to take all three aspects in mind. So this is your legal, technical, and business networks. So as we're defining the systems, it becomes crucial to understand governance of these networks. And this is not just from administration or the need for decentralization or regulatory compliance, but also understanding what does this underlying data structure will look like, and what is the data modeling language will look like. And I think some of the good examples of that would be digital asset modeling language, where it does imply all three of those things at the same time. All right, so a little bit more about Amazon Managed Blockchain. So what we've found is that our customers were getting really stuck on making these things work. So they do launch a POC, let's say whether it's Ethereum, Quorum, Hyperledger, Fabric, you name it, but then they're quickly realizing that blockchains become specialized. And I've heard here a lot of talks on modularity in blockchains, because if you're looking to comply with regulation and business needs, you do need this flexibility. So let's say in Sawtooth, you have a concept of pluggable or unpluggable consensus, to where you dictate the need or the latency for transaction finality by the business rules. So because of that, let's look at let's say Fabric. You have ordering services, you have certificate authorities, you have nodes. It becomes really difficult to manage and maintain, and actually get to where we actually want to go, to where we actually can tell what blockchain is great at and how it can optimize your business. So because of that, we launched a couple of fully managed services, again by customer demand. So there was no other plan except for serve our customers better. We've chose to go with Hyperledger Fabric and Ethereum as the two protocols that we're supporting right now. And also this helps bring down the cost of experimentation. So it's pretty easy to set up the network. We optimized a lot of parts to it. So let's say you can just create network, add users, and start deploying applications. So as far as owning network, I think that's a really important one to point out. When we're looking to build out decentralized service or managed service, we wanted to make sure that it's actually decentralized, so that nobody, not even AWS, can shut down the network. So as soon as a user, let's say, creates a network, they can add another company to this consortium. At that point, they can leave. So we wanted to build in voting mechanisms and ways to onboard and offboard users effectively. So that's something we found that was really necessary to get these use cases to production. So this is I was really excited to actually be speaking at a computer science campus, because I'm a computer science major myself, so I don't think we're going to shy away from some of the technical details. Some of the considerations we're also looking is compliance with regulated industries. So we employed services like VPC Private Link, which essentially allows the traffic to be passed via our own private backbones to where it's never exposed to outside internet. And this is kind of the difference between public and private blockchains, is that you don't want to expose this traffic to the internet if you don't have to, because a lot of the companies that actually have different methodologies in the way they inspect header packets before forwarding them past your firewalls. So this is the reason why we chose to use VPC endpoints and private link. Also, some of the modifications we've done is replacing some of the certificate authorities that were halfway not done correctly, I would say, in some of the just plain vanilla distributions of Fabric, in the way that it did require to either store your cryptographic materials on disk, which is not the best practice. So we've built in some key management and other security services to improve key management. So one of the use cases that I think is very interesting is Nestle. So this is, again, anti-counterfeiting, supply chain. So we're working with them directly on single origin coffee. And if you're looking at geopolitical implications of this, I think it's really important for us to start closing down some of the inefficiencies that we're seeing in supply chains. So start closing down these disparities of income between, let's say, countries in South America and the amount of money I'm paying for a single-use cup. So this is something that we're working with Nestle on. And here are some of the other use cases that please feel free to look into and just see on how we're working with different industries, from aviation to healthcare and life sciences to insurance and even stock exchanges. And QLDB. So we've been using QLDB, which quantum stands for not quantum computing. It stands for a single atomic transaction. So essentially, this is your ACID transaction to where either the entire transaction fails or succeeds. So this is why it's called quantum DB. Long time ago, when we started working with customers, we realized that if you build one-size-fits-all solution, it's not going to fit anyone. So you will see us moving into more specialized purpose-built databases, and Ledger Database is one of them. And what it does, it provides a complete, verifiable record of all changes for systems of records. So this is your accounting use cases, anything that's susceptible to double spend and so forth. So we actually re-architected this solution. We've been using it internally under the hood for many, many years. And when we started hearing about blockchain, a few light bulbs went off, is that this is actually how we propagate all of the transaction and transform them into different services. So you do have complete ordered record of all the transactions, which you will see in the journal, that then can be transformed into the database view and tables. And we can dive into it later on. I don't want to take up too much time. So essentially what we've done here is that we've applied the concept of cryptographic verification to a database, which essentially allows you to verify old transactions, transform them into current and historic views, but at the same time be able to prove via generating a digest. So this is kind of like the tip of your Merkle trees, that nothing has ever been tampered with. And we went even a step further. We made sure that none of the APIs are even exposed to change anything in the journal history. So there's absolutely no way even for us to modify anything as far as the tree of transaction goes. All right, and here are some of the other success stories that I've mentioned. I've personally worked with blockchain partners, and it's been really rewarding to see companies working with us and launching solutions. Companies from Consensus to R3 to customers like Coinbase, Accenture, and actually seeing them define their way and bringing value to our customers. And more than happy to chat about some of the use cases. I think one of my favorite one was Far Mobile, when we've decided to try to solve a little bit of a trust issues with farmers. So how can they monetize the IP that they're creating by tending to their fields? own that data and be able to resell it to interested parties. So we worked with them. We worked with R3 on use cases in commodities trading, digitizing gold, and in case of Consensus, we worked with Union Bank, where we were providing funding to the underbanked in the Philippines. So very cool use cases. Please feel free to read any of the case studies that we have on our website. Congo is an interesting one. So Congo is a commodities trading consortium that went in production. So I think all of us should be watching quite closely what's going in production and learning more from those use cases. So that's one of the first use cases that we saw go live last fall. R3, who I've mentioned. Guild 1 is tackling inefficiencies in royalties management for oil and gas. So we're seeing applications in the energy sector. So I think it's going to be really, really interesting to watch this particular industry as we're moving closer to EV and into electronic panels. And understanding how we can tokenize energy use. All right. So I'm not going to go too deeply into other questions, but here are some links that you can check out on everything I've covered. More than happy to just sidebar the conversation and talk about what considerations we've made as we're building out these solutions, some of the issues that we've had and how we solved for them. And this was a little bit fast, so thank you for your time.
You're just on time. Look at that. Just on time. Maybe one question for Lana while we switch over. Any questions? There's one in the back.
It's really hard. It was a lot of work. So essentially, we just looked at all of the industry leaders and then trying to figure out how real the use case is and how real the technology stack is. And then I personally look at how solid it is. So we evaluate based on 5 principles. So this is your security, high availability. So if you have single points of failure, let's say, or let's say if you have one validating node, clearly that's going to bring down the entire network. So you need to make sure that consensus algorithms do what they're supposed to be doing. And it's a lot of just rolling up your sleeves and proving it out. Reading white papers. And a lot of times white paper and implementation are 2 different things. So you kind of have to do both. Yeah.
Great. Thank you, Lana.
Thanks.
All right, our next speaker is from Moog, Tim Abbott. He's manager of digital transformation technology. And if you're not familiar, if you are from Blocksburg, I'm sure you've driven by Moog. Moog has several buildings in the area. Tim is actually from Albany, right? Did I get that right? Buffalo, where it's predicted that they're going to have a lot of snow in the coming. So I think he came south just to get warm before it goes there. Anyway, and also I'll point out that, as I mentioned earlier, he's a veteran and he was a submariner, so that's a pretty big deal. So with that, let's welcome Tim.
Thank you, Kirk. Good afternoon, everyone. What a great series of conversations that have happened so far. It's very refreshing for me because usually I'm the only blockchain guy at a conference. So it's nice to have this collection of people here and these type of conversations, which are very enlightening. As Kirk mentioned, I'm the Digital Transformation Technology Manager at Mogh. Just to give you a quick overview of who Mogh is, for those of you who may not be familiar, we're primarily a precision motion control company. We really specialize in those controls where the cost of failure are high, whether it's in dollars or human life. You can see on the slide, these are a lot of the platforms that we're involved with. But we are primarily a hardware company. We are not a software company. So what I'd like to do is share with you the story of how it actually came to be with me standing in front of you talking, and explain one of the use cases or how we're using blockchain today and how it applies in our markets and the value that we're seeing to enterprise based on some use cases that we've done over the last 3 years or so. So I go back and give some perspective overall in industry. So we're currently in the 4th industrial revolution. You may have heard the term Industry 4.0. What I want to point out that's different fundamentally from the first 3 industrial revolutions is how we actually perceive our industry and business needs and how we actually communicate our data. In the first 3 industrial revolutions, it's starting with the mass production and the production line, became readily apparent that if you wanted to produce a good quality product over time, you needed to own as much of the supply chain as possible. As you start to progress through the next periods of industrial revolution, we continue to build up those silos and those walls to try and keep all this information as close and under our control as possible, which was how we maintained our competitive advantage. In the fourth industrial revolution, there's something fundamentally different because we're talking about connected devices, connected things. We're talking about hardware taking actions on data, and that data may have come from the organization that's operating the device, or it may have come from somewhere else. So by leveraging all that connectivity, we're also inherently needing to share information in an uncomfortable way. Blockchain helps address a lot of that. I will start to get into that a little bit more, but to our specific use case, roughly about 5 years ago, Moog's been very involved in additive manufacturing or 3D printing. We see the value in that technology for being able to do rapid prototyping and creating new geometries and lighter weight components, which definitely has market value to our customers. But we also started to think, well, what else could we do with 3D printing or additive manufacturing? And really, we did a forward-looking, just hypothetical, what's another great use case for it? And we started to think along some of our customers' lines in the both commercial and military aerospace world. You can imagine a scenario where there's an aircraft down, it's a revenue generation tool that's no longer available for that company or for a warfighter. It's missing a part that maybe Mogh had designed, and they don't have it in inventory, but they do have access to a 3D printer. Wouldn't it be great if they could take Mogh's intellectual property, produce that part closest to the point of use, time of need, and then install it on that aircraft without losing any downtime or revenue? So really, to the end customer, we're really looking, how do we give you as much uptime as possible? In the aerospace world, because we're so highly regulated, almost every part that goes out there has a stack of paperwork that's oftentimes heavier than the part itself. That's to provide the trust and the provenance that that part is what it's supposed to be. It's been maintained and controlled throughout the supply chain up until it gets installed, so that you know that you are safe to fly. Using this point of use time and need concept with a 3D printer, where now the person manufacturing it may or may not be a Mogh person. You don't, how do you operate quality control? How do you ensure that that asset can have the same amount of provenance as trust as you would get out of a traditionally manufactured part? Especially now that you're talking primarily a digital asset. So when I'm talking digital assets as opposed to cryptocurrency here I'm talking about digital assets of what I'll call substantial size, so kilobits or greater, technical data packages, 3D drawings, print files, anything that goes into representing that digital part that you want to convert to a physical part. There's a lot of opportunities when you're transporting a digital asset for it to be intercepted and manipulated. How do I, as an IP owner, know that the person at the other end is only going to produce what I want them to? And with some of these fundamental problems we were trying to address, and we didn't have a technology to do it, and roughly about 4 years ago, we literally stumbled across blockchain. And as we started to learn more and more about it, we said, wow, this could probably fill those gaps that we have to enable this point of use time and need digital supply chain. Over the last 3 years, we've actually taken blockchain and created some we've created some proof of concepts and some use cases. And we've actually, earlier this year, did 5 demonstrations with the Department of Defense and 1 with Air New Zealand, leveraging blockchain to close those gaps. And some of our learnings, other than the value that in the immutable data, is it also really allowed interactions between organizations to be codified. And it provided that, as we saw earlier, that just decentralized trust, which is a very big impact, and it really was critical to enable that workflow that we were talking about. So on the screen now is really a breakdown of the demonstrations that we've done. So the demonstration that we did in April with Air New Zealand, they actually had an aircraft take off and simulate damage to a part. They did not have, the aircraft was able to radio back down to their maintenance facility in Auckland. They did not have inventory of the part on hand. They were able to log into the system that we created using blockchain, which gave them a digital catalog. So we gave them access to view our IP. They were able to identify the part that they wanted. They have a MRO, a maintenance repair operations supplier called ST Engineering in Singapore, who manages not only their physical inventory, but now their digital inventory. They were able to place an order for that digital part. ST Engineering was able to acknowledge that order. They did not have a 3D printer in the LAX area, which is where this aircraft was going. Mogh did have a qualified printer. They were able to then forward that order on to Mogh. Mogh was able to accept it. And for that translation to happen from aircraft to Mogh accepting the order was about 9 minutes. And that went from aircraft to Auckland to Singapore to LA. We were able to deploy a mobile printer, print the part, and that part was off the printer ready to be installed with all the provenance required by the FAA and the regulatory bodies before the aircraft touched down. So this was all done while the aircraft was in the air. So that, from a supply chain perspective, is a huge amount of time reduction and impact to the operational availability, and then you put it into a critical application of a warfighter, and the benefits are gigantic. You can see in the middle, I do show that blockchain's there. So we did structure this so that the blockchain captured all the transactional data, who did it. We also used it to tie it back to the original source information, the requirements that that part was designed to. It tracked all the part releases, so all those transactions were recorded on the blockchain. We used it for person identification and authorization. So all of these things that we've heard talk about earlier, we actually went through and created this, but it also pointed out some large challenges with blockchain. We heard in the last panel discussion that there are a lot of use cases and applications out there where blockchain by itself is not enough to solve a problem or provide the valid use case. When you're talking about technical data packages that are megabytes to terabytes in size, it's not a good thing to place on a blockchain. But the blockchain is a great place to show the evidence of what that file is to ensure that it's not corrupted. It's a great place to log the transactions that happen to that part and the order placement process. So we're able to establish that entire workflow. I also did mention that we utilized it for workflow enforcement across disparate organizations. What it became apparent to make that actually of value, you couldn't just have the blockchain operate as just a ledger, because if you were allowed to pick and choose when you were appending data to the ledger, you don't really get very much value. So what we had to do was establish the blockchain as the sole source of truth. So every transaction started and completed, whether it was a logging of a part or an order placement or a file transfer, all those requests started on chain and were not considered complete until the corresponding transaction was logged back into the chain and gone through the consensus algorithm. Just trying to be cognizant of my time here. The other thing that we did with this was we also managed to keep the IP in the IP owner's hands as long as possible. So for 3D printing, there is a file that does have to get transferred to the printer, but all the other supporting information, 2D drawings, CAD files, specifications, there's no need for those to be transferred. You just need to be able to provide the end user access. So we're able to establish that. Earlier this morning, we heard some of the concerns around transparency. So we had to provide transparency to enable auditability, but we were able to do it in such a way that you obfuscate all of the data. So it's really just a collection of hashes, and those hashes may represent an identity, they may represent a file, they may represent an order placement, but only the parties that were involved in that transaction are able to actually decipher what that information was. So you still have auditability, your visibility or transparency is in a controlled fashion, and that way we eliminate some of those concerns around having certain business processes that you don't want fully transparent, limitedly transparent to provide value. So some of the lessons learned as we went through the implementation of this. So we started off at a use case. So we really started off in the traditional product launch type application. So we had a problem, we wanted to solve it, we created the solution, which then drove us to create a blockchain. That got us through our demonstrations, but now you start to look at how do we actually make this work in a market or in an ecosystem, because blockchain truly is an ecosystem level enhancement and enabler. For us to get there, for that work that we've done so far to become viable in the marketplace, we need to have market or ecosystem level governance implemented, and for that to happen, we actually need to have a market or ecosystem consortia. So here we are down as we're a tier 1 supplier to a lot of OEMs. We are not in the right place in the value chain to drive the establishment of an ecosystem or a consortia by ourselves. We think with our use case, we now have enough to bring people to the table. And what we're starting to see now in the aerospace industry, the Aerospace Industry Association is actually now trying to form consortia so that we have that predefined requirements and governance for general blockchain use in the marketplace. As you start to establish blockchains in these use cases, they will each have their sub-level governance and consortia most likely. But now you've created some place for these new use cases to be easily deployed because a lot of those legal questions, those governance questions, the initial implementation challenges when you're starting without any other market examples will already be worked out. So you allow those ecosystems to grow and be dynamic and provide new value in as timely a fashion as possible. Once we do start to see these consortia form, now you're going to start to see, as I mentioned, those additional use cases show up. Not only that, there will not be one chain to rule them all, most likely. So you're going to start to see different chains with different functionality to support different processes. So we've addressed the workflow and the part validation and the provenance aspect. Trade compliance is another aspect. So now I can give positive identity to trade compliance, and that can interconnect back to my parts traceability and provenance side. Counterfeit mitigation, logistics, shipping and handling, all of those, you're going to start to see these start to evolve, and you're going to start to see these change, although they may be disparate chains, will start to interact with each other, and you'll start to see assets being able to change hands amongst those chains. And there are companies out there working on how to translate that information so you don't encounter the double spend issue that the original blockchain concept was created for around Bitcoin. So I think at that, I've already dumped a lot on you at that point. I've got about a minute and a half or so, so I'd like to see if there's any questions at this point. So we used the Ethereum blockchain, and thank you for that question, because one thing I forgot to highlight, a few mantras that we had in place. We wanted to be blockchain agnostic, and we were endpoint agnostic as well. So we did use Ethereum, and we hosted it in Microsoft Azure cloud as a private, more of a federated type permission blockchain instance. But on the endpoint side, we also wanted to be able to interface with ERP systems or MRP systems, or if it's just a mom and pop access database that they're running their business on. So this entire ecosystem platform model that we created was able to operate without requiring any installation of software. You would be able to API in to get the key information on an authorized basis from any of the organizations involved.
One more question?
Yes. So I was that a CryptoKitty reference? Yes. So yeah. So I didn't catch all of the question, but it was along the lines of worrying about the effect or similar effect of what happened with CryptoKitties to the Ethereum network. Are we worried about that? How that would impact this type of ecosystem when you're doing business processes? For those of you who are not aware of CryptoKitties, this was basically a DApp on the Ethereum network that was created during a hackathon over a weekend. It was basically like these individual kittens that you could spawn each other and you could collect them. Think about the Beanie Baby craze from the 90s, if you can recall those times. That created so much popularity, and Ethereum, its network throughput was very slow, and through its consensus algorithm, when that was released, there was so much interest in it that it completely bogged down the entire Ethereum system. What was normally going to take about 10 minutes to process went to 10 hours or greater, almost shut down the entire thing. The way that we've addressed that is, again, going to the permission side. That's going to be part of the consortia's large discussion points, is going to be evaluating that technology stack so that we address those types of concerns. So the nodes and the servers will not be part of a public network, most likely, just based on our regulated space. But the throughput and the understanding of those type of new challenges that we may not be aware of and how we can correct for those will be very important. But we want to do that at the market level so that we're not excluding any key stakeholders from the decisions.
Great, thank you, Tim.
Oh, thank you.
All right, so our next speaker is John Fields, and a couple of things about John. First of all, we can't hold it against him that he has a UVA degree. That's the first thing I'll say. Oh, there's a couple in the audience. And the second thing is he brought his 11-year-old son who's here. I won't make him stand up or anything. But he put down the video games just to come see Dad and cheer him on, I guess. And what I was going to say is to make up for going to UVA, what you could do is send your son here for computer science. And I would also point out that Capital One has hired a lot of our CS graduates, so father and son could work together in the future. How about that? All right. Wes, welcome.
Thank you. Mic check. And let's see. I guess I do that. All right. Hey, I'm really happy to be here. I actually tried to come to tech a while back, but it's actually a better story. I actually could have come here, but I actually went to another school down the road where they let me play football, which was probably not a great decision at the time, but it was one of the best things I ever did for myself. So, yeah, so a little bit about me. So I'm a product manager on the digital developer platform at Capital One. Our brand name is Dev Exchange. So we offer APIs, and that's the portal for which you would connect to Capital One, exchange data, call APIs, what have you. We just went through a partnership with a company you may have heard of, Walmart. So we had a lot of activity in that space. I am a recovering app developer. So I got into product management by building an app. I still miss developing software. I try to do it when I can, but I am very much a product manager nowadays. I did get a bachelor's in computer science, so hopefully I'm okay in this room, and then went on to get a systems engineering degree. So saying all that, what is it I do? I think it's best summed up with asking the question, how can we best meet our customers' needs with the technology that enables us to do what is just now possible? So you could imagine Capital One is very interested in things like machine learning, AI, and blockchain. So I was asked to come over and work on emerging tech earlier this year. And one of the things that we wanted to look at is what should Capital One do with blockchain? And for those of you who are not aware, Capital One is a bank or credit cards, commercial bank, auto finance, financial services. And I was a little bit unsure about this at first. It felt like blockchain was a solution in search of a problem. And then what I came to understand is, look, there's a lot of passion around technology, especially at Capital One. It's a great place to work, and we often describe ourselves as a software company that happens to be a bank, and that's very true. And as I looked around the organization, I saw through our GitHub that we were already experimenting. We had numerous projects out there, not in production, but we like to explore, we like to learn at Capital One. And so what I came to realize is it's not so much this is a solution in search of a problem, but the problem is how can we best use this capability to better our customers' lives? So I'll get into the presentation here. I should probably note most of these opinions are my own, relaying what I've learned this year and how I see things. So I want to start with a question, and this is the first time I've given this talk, so I'm going to need some help from the audience. I need someone to tell me, what is a Bitcoin worth? Speak up, please, don't be shy. However much people will pay for it. Yep, we have the market answer. Any other answers?
The same as a win over UVA.
Same as a win over UVA. Say it again. $8,794. Any other answers? Whatever you're willing to pay for it. That's also correct. In terms of value, though, how do you assign value to the Bitcoin? I heard an answer expressed in terms of dollars. Are there any other answers that we can express in a different term, other than, yes, what the market will pay? Say again? Yep, that's more of what it is, but how much do I know this how do I know how much this Bitcoin is worth? Go ahead. That's another way to look at it. I think the point of this question and I kind of set everyone up for, is it's very difficult to express value without using the term dollars. And let's ask another question. So I imagine there would be a lot of future graduates in the audience. And let's say you were given a position, a job, and you were given the option, 1 Bitcoin a month or $8,800 a month. And when I put this slide together Friday, Bitcoin was worth $8,800. Who here would say I would take the 1 Bitcoin a month salary? Got it. A couple of hands. Okay, I thought this might happen. All right. But you say that even knowing that Bitcoin was down to $3,000 earlier this year. A lot of volatility, right? I, with a mortgage and a son, would probably take the $8,800 a month job because I kind of want to know that I'm going to be able to pay my rent this time next year. Maybe if I had less obligations, I might be a little bit more adventurous and take the job as being paid as 1 Bitcoin a month. And we've talked about the dollar a couple times already. So what makes the dollar so special? I think there's 2 very good attributes, and then a third that we'll get to on the next slide. One is very stable. You look at the chart, it maybe doesn't look so stable, but the dollar has been very, very stable for a number of years. And we hold a dollar, it erodes a little bit, there's time value of money, but I'm pretty sure that the dollar that I hold in my pocket today is going to be roughly worth $1 tomorrow, whereas we don't know that with Bitcoin. So thinking about what we can do with blockchain being a platform, a technology, it's very often conflated with, and very often the first thing people anchor to, cryptocurrency. So as I looked at the question of what can we do with blockchain, I thought about, well, what does cryptocurrency mean to Capital One? So we had to understand, or I needed to understand, and maybe some of us already know this, what it means to have a currency and what is already out there in the market. And of course, the dollar is sort of the most favored treasury amongst all nations, which I confirmed by looking on the internet today, is 70% of all the foreign exchange reserves in the world, the next currency being around 30%. So the dollar is very favored. And then the next slide I'm going to share against the advice and better judgment of myself and my friends. You may have seen this joke, but I think it helps tell a story. Some people would tell you that there's 2 kinds of countries, those that use the metric system and those that have landed a man on the moon. Okay, that'll go out in the next one then. But I do think it is very pertinent to think about what is behind the dollar. Capital One's mission is to change banking for good. And I really like this mission statement. I didn't come up with it, but I really like it. And it's an intentional double entendre. To change banking for good means to change it for the better and also to change it forever. So Capital One's very interested in what does this technology help us do? What is just now possible? But if our mission is to change banking for good, what is banking? Well, it's payments, and I think Bitcoin has done a phenomenal job of enabling payments. But as I've come to understand in a very real way, payments are just the top, just the tip of the iceberg. In addition to payments, you have settlement. You have credit, which we'll talk about in a minute. It's a very important part of the economy and something that's very valuable to us all. Regulations, and in the last panel, they did a great job of speaking to some of the regulations that we have as a bank that are important to the economy, and I would argue are well-intentioned. AML being anti-money laundering. If you are not doing anything to help protect against, I'm going to say the bad guys, then your system could be used in ways that you would not want that to be used. And it could be some very real, terrible consequences. KYC, know your customer, and SAR. So when someone submits a transaction at the teller window of a certain cash amount, we have to fill out a SAR. Who submitted all this cash? And of course, that's to try to help catch the money laundering. Also involved in this is the central bank, which is important. It helps set the monetary policy. And that helps us create credit. So how did we get here? Does anyone know the origin story? If you do, then I'm going to invite you to tell it better than I do. But this is not a new thing. Banking is certainly not a new thing. The first feature of banking is a ledger, which I think is very pertinent to today's conversation. And why is a ledger important? Because it gives us the ability to move money forwards and backwards in time. And what else are we doing with credit if we're not moving money forward in time? And I would ask, why is credit important? Why do we have a better economy when we have access to credit? And further, I would ask, what's an important value of credit? It's that your monetary policy, your currency, is stable enough so that if I loan you 100 whatever, and you pledge to pay back 100 and change, that's going to have mostly the value I expect it to have when that credit instrument comes due. So I'm going to do a little demonstration, and I would ask you guys to help me. So the panel actually didn't talk to me about this before. I didn't talk to them, but you guys all need a loan. And fortunately, I have my ledger, and these are all the deposits from the good people here. So there's a finite amount of pages in this book, right? It's the same book we all got this morning. But if you need a loan, and I give him currency. And since I'm short on time, I won't go through the dramatic effect of doing it across the board here, but he now has the money. The money's still on the books. There is now more money in circulation, right? Does everyone see that? Being able to loan out the money means Dennis, who has a great business idea, who just needs a little capital to go do a thing, can now go do that thing, employ people to do that thing. And by being able to provide credit and move money forward in time, we can now grow the economy. So it's very important. So looking, again, coming back to how we started this, we have the US dollar, we have a banking system. We've been looking at it for a long time. Having assessed the situation, I figured, well, maybe cryptocurrency is not so appealing to Capital One at this time to try to dig into. But again, what are we doing at Capital One? And I've said this before, but I wanted to underline and highlight this. That it all goes back to how can we help our customers' financial lives? And so as a product manager, it's my responsibility to think about, is this good for our customer, and can we serve our customers better? So we looked at crypto. Again, everyone, when you talk to them about crypto, they sort of anchor to Bitcoin. Figured out that maybe crypto is not the space to look at, but what about the underlying technology? The platform that is blockchain. How can we use that? And let's say that we're ready to do something. We are ready to build, explore, experiment, what have you. You have really two options. We can take something that's in the existing system and replace it. And a lot of the potential applications of blockchain that's been talked about today and talked about worldwide are sort of replacements for what we already do. Or we can do a new thing that's probably going to be good using blockchain. So now you have two problems. Now you have to figure out the new thing that's probably going to be useful. And now you have to also convince everyone that blockchain is the way to go. If you decide that, okay, I want to learn about blockchain and build something to replace something that's already there, you then have to convince the person that owns that business, that has the P&L responsibility, that it's worth the risk, that it's worth the trouble, the time, the effort, the money to do that. And it's very difficult to do that. So from my experience, it's a little bit easier to do the new thing. You just have to find the new innovative thing to do. And here's sort of summed up what I came to this year. And I've said this before, but I want to underscore this. Blockchain is a platform that has great potential. I'm as excited about blockchain as anyone else in this room. To build upon blockchain, to get started, you have to find the right use case. It's either replacing something that probably already works, and we've probably already spent a lot of money on, or doing something new. And if you get that idea, if you have that innovative idea, that notion of doing something new, you probably have the option of building on a more traditional stack, a database, API, what have you. And I think you have to allow for the fact that saying we're going to do this on blockchain is going to raise some eyebrows. It's going to create some risk in the project. And if you are looking at something that is decentralized or distributed amongst multiple network partners, now, not only do you have the change management to reckon with your own company, yes, you have to also manage the change curve with your external partners, which makes it even more difficult. So, pro tip on that, it can be very difficult. So again, just to underscore Capital One's position on this, we're very interested in all emerging technology, AI, machine learning. We've definitely been able to leverage machine learning and blockchain. But in order for us to really say, yes, this is the right path to go, we have to map it back to our customers' lives and understand how this provides value to them. This last slide I almost didn't bring in, but I'm going to say this is sort of general advice. As I did the tour this summer, different conferences, a couple of things were shared out that I think are important to sort of internalize. Start small. There will be change curve to manage. Don't look at your core business. Look at something on the outside, something that supports your core business. Again, to understand the risk. My advice would be to start with private and permissioned networks. Don't just re-platform, because it's going to be difficult to make the business case for that. And then once you've done that, once you have your project and once you can demonstrate value using this technology and you understand the risk, then you can expand on that value by building on blockchain alongside that side project. Thank you. I'm going to need that loan back.
Maybe one question while we change over. Any questions? No, we'll have more time for questions in the enterprise panel as well, which I think you'll be on, right, John?
That's right. Thank you.
So, okay. Thank you very much. Very interesting. So I'm going to point out while we bring up the next speaker, Dennis Gatens, that look at the diversity we've had so far: web services, additive manufacturing, digital asset management. And now for what it was a Monty Python, now for something completely different, right? Completely different. Yeah, so what about blockchain in space? Space. Yeah. Should have had those guys over there. Thank you. I'll be here all week. All right. So Dennis is from is a chief commercial officer at a company called Constellation, and I'll leave it at blockchain in space and let you do it from there. How about that? All right. Let's welcome Dennis.
Thank you. Everyone hear me all right? I usually talk pretty loud anyway. So I'm not in the wrong room. I'm not at the wrong conference. But by the slide and title, you might think so. So I'm going to start off, learning how to use this. Giving you a background of who we are. We are a Cloud Constellation Corporation. We came into existence to basically lead the cloud transformation of space. As many of you might know, there's a commercial space or a space 2.0 that's underway. There's a lot of planned global networks that will be in space shortly. When I say shortly, next, say 3 years. But we're focused on, and that's broadband connectivity, we're focused on cloud services, specifically solving one problem, which is data security. So we refer to it, our brand is Spacebout, so I got to give you a little bit of later groundwork here, who we are and what we're doing, and you'll see where blockchain fits into it very nicely. And as I said, I need to get trained. Am I going the wrong? Yes, I'm going the wrong way. How do I go back? Oops. Got it. I just told you the entire story. All right. So we are building a LEO constellation in order to provide security for data. What we're doing is the combination of global connectivity without touching terrestrial infrastructure. So we will provide global connectivity for enterprise customers directly into their enterprise facilities and infrastructure on a global basis, utilizing a satellite network, and then on satellite providing data storage. So you can have your data at rest or in motion on a global basis without touching terrestrial infrastructure. So why is that important? We'll get to that. So you can think about it as the ultimate air gap security. So Spacebout, yeah. So data security as a service. It's a constellation of 10 satellites, which architecturally is quite different than you hear about these mega constellations with thousands of satellites and a mesh configuration. But we utilize 10 satellites, and we utilize geosatellites above us for the communications to and from Earth. So first of all, there's no connectivity directly to our network, and the only way to connect to our network is via one of our geo partners, in Intelsat and SES and others who have global coverage. So with a combination of 10 satellites in LEO, one of them being a hot spare, and 3 or 4 geo partners around the world, we provide global connectivity. So you traverse the geo portion of the network up to ours. You then can be routed around our network with optics. We use photonics and counter-rotating rings to connect the 10 satellites. So we have 2 counter-rotating Ethernet or optical rings, basically a layer 3 ring topology in low Earth orbit. These satellites orbit the Earth at the equator, so they fundamentally rise and fall underneath the geos. We communicate up the geo, or traffic communicates down to us. We rise, we then fall, the next one rises, so we make before we break, basically, as these our satellites rise and fall underneath the geo partners. So this way, you have complete isolation from the terrestrial infrastructure with the only way to access our network via our geo partners. So that's the fundamental premise of our cloud infrastructure. So on the satellites, we store data. We also can provide edge compute capabilities. So we can run analytics-based applications, machine learning applications, and we can run blockchain-based applications. So I think I walked through the value proposition pretty clearly. It's fundamentally a new way of storing data and retrieving data without touching global terrestrial. So the cloud transformation of space. There's been a lot of activity. All of the traditional cloud services providers that we all know and love have all, for most part, have developed relationships with the traditional satellite services providers. So you have this integration of satellite networks and cloud services underway. The part of it's driven by the expectation for IoT. It's also a way of providing just a global connectivity for cloud data services. Second, you have the emergence of satellite data suppliers. Many of you probably know Hawkeye. One of the founders is a Virginia Tech alumni, Charles Clancy. And then the emergence of cloud service providers in space, and that's who we are. So one of our strategic relationships is with IBM. So IBM is looking to put Watson in space on our satellites. They're looking to run blockchain-based applications utilizing our satellites, and I'll get into the applications as we see them here shortly. But so I think this has been well covered. Data is basically the strategic asset for any company. It's the new oil, it's the new currency, it's the new gold. The valuation of companies is driven significantly by their data, the asset, and the perceived value of that data. Just some key points. For example, 4 of the top 10 largest companies in the world are data companies. From the U.S. government's perspective, and I'll get into this a little bit later, it's critical for national security, and it's mission critical to any activity underway around the world from a U.S. government perspective and DoD perspective. And back to my previous slide, here's one estimate for IoT, 125 billion endpoints by 2030. Everything from your doorbell to whatever else in the house they can put a internet browser in. So this, if you look to the right on the chart, you can see where our focus is, from healthcare to finance to government to oil and gas. These are significant impact on our GDP, those strategic assets and the monetizing of the data assets. So impact on any of those organizations can conceivably have an impact on our economy. But we know it happens. It happens all the time. We hear of events almost on a weekly basis in the mainstream media, and the numbers are pretty staggering. If you think about trillions of dollars of lost cost to businesses around the world, it's a significant transfer of wealth within our economy. And again, as you'll see in a couple of slides, the threat to national security is very real and of great concern to a number of government organizations. So why is the terrestrial infrastructure such a, we use it every day. We talk around, we communicate around the world every single day practically, but it's highly vulnerable to attack because there's millions of endpoints, thousands of networks that have been cobbled together over time. So it's literally a network of networks. There's thousands of service providers and dozens of backbones and exchange points. One of the most classic situations occurred a couple years ago where an age-old protocol called BGP, some of you might be familiar with it, it literally got hacked and traffic was being routed that was supposed to go East Coast, West Coast, was going across the Pacific Ocean. Not a good thing. So that's how vulnerable it can be. No organization is immune. We all have networks. We all have internet access, broadband connectivity. I'm not sure what happened to my slide there. But, and then, hopefully there's nothing obscene in this slide now. What's really interesting is a recent study, the five most hacked or impacted sectors are government, financial services, healthcare, manufacturing, and transportation, ? So now, insult for injury, there's the evolving regulatory environment. GDPR is in place, and they've been very busy. California and New York are setting the standards for the US. And this number I just pulled as I was preparing these slides. In 2019 so far, GDPR has levied that 358 million euros of fines. Now, will they collect all that? Probably not, but they have the ability to, as I said, add insult to injury in a significant way. So you have that's always a consideration for any cybersecurity strategy. All right, finally, blockchain. So this is how we see the intersection of blockchain, and I'll mention IBM again. This is their view of the world as well. There's a significant set of use cases across, these are four verticals that we focus on, from healthcare, oil and gas, government, defense, finance, and don't call it cryptocurrency, it's digital currency as we see it. But we just prefer that term, frankly. But it is the evolving market for the use of digital currencies around the world. A number of these have been spoken to, securing the chain of custody associated with data of many types, from patient data to research data, building trust, another layer of security and trust into government networks, whether it's the data itself, it's the delivery of applications to satellite networks that might run on an edge compute platform in space for mission-critical, mission-specific situations in certain theaters of the world, to acting in the finance world, cold vault storage capabilities, and the ingress and egress of data from a cold vault storage environment for digital currencies. In oil and gas, the trusted delivery of data, once it is collected in the remote sites, becomes highly valuable, highly competitive data. You want to make sure it's riding a trusted network. So we can reach all these types of enterprise organizations. We connect directly into their network, and we can run blockchain-based applications operationally as part of our layers of security, and we can run blockchain-based applications for transaction-type services that were mentioned. I think Lana mentioned it as the two basic concepts. Speed up. All right, so use case. So most of you are probably familiar with DARPA. They are building a prototype network in low Earth orbit as the first step towards the strategic objectives to have a significant presence and set of capabilities in low Earth orbit for DoD, which you'll see on the next slide. So it's 20 or so satellites with the goal of showing the ability to communicate across a mesh-like network and the ability to collect data, bring the data back to Earth in a highly secure way. So they're prototyping that. So the next, gosh, slides again. The Space Development Agency notional architecture is layers of capabilities in LEO. So now we're talking hundreds of satellites that provide everything from sensing, locating, and then providing layers of analytics so that the decisions are made very quickly, very securely, and action is taken in battlefield environments. And the SDA's mission is written into the National Security Strategy, the most recent National Defense Strategy, sorry. So you can imagine that the blockchain capability, the trusted ledgers, the layers of it that could exist within this network in low Earth orbit. And this is separate from what we're doing, but we see how we see ourselves fitting into this. And in fact, DoD now has a strategy for implementing blockchain into their overall infrastructure, particularly supply chain, which is what this is all about. So when you build a satellite, you got to be sure that every single component has been said here, comes from the proper source, that there is no compromise of your sources for components that go into a satellite, because either it can be commercially disastrous or it can be have a significant impact on DoD operations. If there's something that is nefariously inserted into a piece of silicon at the source that ends up in a satellite, it could be a disaster. So, and this is an IBM graphic. They see the value of a blockchain in the supply chain for the manufacturing of satellites, the regulatory requirements to launch satellites and place them in orbit so that we can run a network, and then the handoff from manufacturer to launch services provider, and ultimately to placing it in orbit and handing it off to the service provider such as us. So talked a little bit about this. This is the use case in the military DoD space. We, as I mentioned, we work with IBM. We've been in discussions with AWS to run edge compute environments for them as well. But the resources capabilities we provide are data storage, global enterprise connectivity without touching terrestrial, edge computing, and then blockchain trusted communications capabilities. And these are all very important capabilities for next generation architectures for DoD. And as you can see, it can be facility to facility and also into the field, where certain places on Earth, there's no cloud infrastructure on Earth, there's no trusted cloud infrastructure on Earth, or it's just not reliable. So being able to go right up to a cloud infrastructure from the location is a highly desired capability for DoD. Space Chain. Anyone heard of Space Chain? So their mission in life is to build a space-based blockchain capability. They're working with their own space chain. They call it Space Chain OS. It's an open system. I think NG is next generation. I'm not sure what happened there. So their mission is to develop an infrastructure in space that provides blockchain-based services. And the company is called Space Chain. They're Singapore-based. They're a partner of ours because they want to use our network and our data storage capabilities and potentially our edge computing. So this is really interesting from our perspective because it plays with the value of our service offering. The value, the impact to businesses is just significant in terms of the capabilities and the efficiencies brought to organizations. And I'm quoting Gartner and Deloitte here, hopefully they'll agree with me, but it is seen as a significant impact in terms of technology breakthroughs. I think of the cloud as an industrial revolution in itself, and as I think was mentioned earlier, it's a similar value proposition as the internet. So, the emergence of blockchain as a service, you got the technology, you got the development support for your specific applications, and then you got a cloud infrastructure to run your blockchain application on. And all the usual suspects and players are participating in that. All right, so kind of pulling it all back together, from our perspective, there's two innovation curves. There's the hacker innovation curve, and then there's the cybersecurity innovation curve. And obviously, you want the stronger curve to be the cybersecurity strategies, and we believe that we're part of that. The impact on an organization from customer loss, brand equity loss, the financial impact, the impact on focusing on your strategic objectives is significant, and then, of course, there's a regulatory impact. Space-based cloud services and networks, they're on their way. They're a few years out. In my opinion, from our perspective and what we're trying to bring to market, blockchain is going to be a fundamental layer of technology associated with it. So I am an alumni. I'm very happy to be back on campus and spend a few days on this gorgeous campus with 2 nice days of weather, and of course, tomorrow's going to be different. And there's not many chances you get to put the Hokie bird in your slide deck. So I enjoyed doing that on Friday afternoon. And the last thing I have to say is go Hokies, win out. Anyone from UVA here? Oh, yeah. So. Questions, or am I out?
How do you power that?
Solar powered. Yeah, I could do the swap. I could go through a swap with you in detail, but it's all size. I mean, it's size for the processing. The satellites are designed, so the processing requirements and the memory storage capability, the volume, mass, and power have all been sized out. So I don't know the exact size of our solar panels, but it's all been spec'd out.